This is Geometry, Unit 4, Day 8. We're proving triangles congruent by angle side angle and also angle angle side. So when you look down here, we're looking at our postulate that shows us that we have two angles and the side in between. That is called the included side. It's in between our two angles. So if we have an angle A which is congruent to angle D and a side coming off angle A, just like the side coming off angle D, that's DF, angle C that leads into that angle C, well, this side leads into angle F. Well, we have an angle followed by a side followed by another angle. Two angles and the side in between. So if we look at this first triangle as triangle ABC, then we're going to name this one DEF. Angle side angle. You have two A's and you have the S that's in between those angles. Another way you could have two A's and a side that is not in between those two A's. So if you have the A, which matches with D, and then you don't have the side right next to it, you have another angle that matches with angle F. Then next to that one leading around is the next side called BC. We're going to call this EF. So now we have two A's and we don't have the S right between it. We have the two A's and the S that's on the outside. So angle followed by angle, then a side. We have triangle ABC would be triangle DEF, and that again would be by angle, angle, side. So we're going to look here at example 1, and we're going to look at different options. Can the triangles be proven congruent? Well, here I know we have two A's, so we're looking at maybe an AAS, or we're looking at an angle side angle. Do I know any more information? Do I have any sides the same length? Do I have a midpoint? Anything like that? I don't. The only thing I could talk about here is that you have vertical angles. So all I have is angle, 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 which does not prove triangles congruent. It does not prove triangles congruent. This next one, I have an angle with two tick marks. I have an angle with one tick mark. I have that for both triangles. So I have two A's. The question is, do I have a side that's the same? I don't have a midpoint, but I do share an exact side. There's a side, it's called the reflexive property. So now I have two A's and the S that's next to it. So that's called angle side angle. And angle side angle shows triangles congruent. In this case, it looks like we have two sides that are marked. We have a pair of angles that are marked. So for each triangle, we have an angle and a side. We need to come up with another side or another angle. The angle that we have the same are the vertical angles. Whenever you form a big X, you know that you have vertical angles. So this is going to be two A's with the S in between. The side is in between your two A's. So angle side angle shows triangles congruent. Remember, when you're looking at the two angles and a side, they have to be in the same triangle. You wouldn't cross over triangles and say angle, angle, side. You have to stay inside the same triangle. We have two A's inside this triangle and the side that's in between them. Angle, side, angle. The S is in between the A's. This next shape here, we know that these are the same. That makes that the midpoint. We know we have right angles. Right angles are always congruent. So we have those the same. Do I know any other sides? Just because this is a midpoint does not make the other direction a midpoint. So you can't guarantee that. But we do have vertical angles. Makes a big X. They're going to be congruent on either side. So now I have two angles marked and the side that's in between those angles. Angle, side, angle shows triangles congruent. This next one, we have two S's in one triangle and two S's in the other triangle. But the angle that we have is the non-included angle. That's not the one in between the two sides. So this, you could say, it looks like ASS or SSA. Sometimes people can remember that SSA does not work, mainly because a good way to remember, perhaps, is that of what it might spell going the other way. It just helps you remember, compared to all the other options, this is the option that does not work. Angle, side, side, ASS, does not work in terms of showing triangles congruent all the time. Which does not prove triangles congruent. It does not prove triangles congruent. There's only two ways that don't work. All the angles, AAA, and two sides of the non-included angle. Here we have two A's and the non-included side. So we have angle, angle, side in both triangles. We have a one ticker followed by a two ticker followed by one line, and that's the same order we have over here. So angle, angle, side, just like it has earlier in these problems, shows triangles congruent. On the next page, we're looking to see if these two triangles are congruent. It's difficult to see which triangles what we're dealing with. Are we dealing with the small ones? Are we dealing with these two triangles? Those two triangles, the bigger ones. They're asking us to prove triangles STW, STW. So that big triangle with VWT. So we got two big triangles. You have to use your eyes, trace it out with your pencil, your finger. What I would suggest is to retrace whenever you have your triangles overlapping like that. Retrace it, S, T, and W, T, W, and V. These two angles are both 60 up top. That's not the important part. The important part is that they're the same amount, so we'll put one tick mark curve there. These are a right angle, so I'll put a box in the corner. Now, do we know anything else? Some people get carried away and they talk about vertical angles, but point U is not part of our triangle, so that doesn't help us. The side that is the same is TW. TW is in both triangles. I'll use two tick marks for fun. So now I have two A's and the side that's in between that. So I can say that triangle STW is congruent to triangle VWT because of angle, angle, side. Over with the next picture. These two triangles are not overlapping, so it might not be as necessary to redraw the picture. We can see the only triangles we have, STW and VWT. Both triangles have a right angle. Both triangles have one tick marker. Do we know anything else for sure? Do we have a midpoint? Do they share the same side? That they do. They share this side right in between. So in one triangle we have two A's marked and the side that's in between those A's. So we have side, angle, side, and the triangles that would be congruent would be STW, S to T to W, so we went from an angle to the right angle to the one tick mark. So now we're going to say triangle VWT, from the angle to the right angle to the one tick mark. Is it possible to prove the triangle is congruent? Here I have a pair of lines that are parallel. If you have parallel lines, remember one of the shapes you're looking for is a Z. So here it looks like I might have a zigzag or a Z. It kind of looks like an N almost. But I would have that angle congruent with this angle. So I have two A's in our triangle. We also have the side that's in between those, the one that's being shared. So I know that triangle KLN, no tick mark, one tick mark to two tick marks, should go with MNL, no tick marks, one tick mark, two tick marks. So this triangle is congruent to that one by angle, angle, side. Two A's and the S that is not in between. Oh, I'm sorry. We got two A's and we have the side in between. We have two A's and the side that connects those two angles together. So yes, angle, side angle. Over here, TXZ. See how they're overlapping some? So I would suggest, let's redraw them. So you get T, Z, and X. You get Y, W, and V. The X gets a single curve. The Y gets a single curve. I see that this side here has a 3 tick mark and a 1 tick mark, and so does this one, a 3 tick mark and a 1 tick mark. So I know that these happen to both be the same. On this side, I get a 2 tick mark and I share that YX, and this way I have a 2 tick mark and I share that YX. So they're the same also. So I'll give them 2 tick marks this time. So here I have two S's and I have the A that's in between those S's. Two sides and the A that's in between it, side, angle, side. We're going to tell whether you can use the given information to determine if these triangles are congruent. So I would suggest to start with your triangles, label them JRM, XYZ. We'll come in and label our parts. JM is congruent to XZ. Angle M is congruent to angle Y. Angle J is congruent to angle X. So here you have angle side. Whoops, you have two angles with the side that's in between. And this one you have two angles with the side not in between. They're not sharing the same pattern. So in this case, that would be considered not congruent. So now we'll come over to their next set. JRM XYZ. JM would have one tick mark, XZ would have one tick mark, JR has two tick marks, YZ has two tick marks. Angle J, the one in between the two sides, angle X. Oh, look at that. This is not in between the two sides. This one's in between the two sides. Again. Not congruent triangles. So we're going to have J, R, M. We're going to have X, Y, Z. R, M, Y, Z. Angle M and Z and J and X. So yes, in this case, both triangles have the same pattern. They have two angles that'll match each other, and they have the side that's not in between those angles. It shows the triangle is congruent. JR to XY, RM to YZ, and JM to XZ. So we're going to label our parts, JR with YZ, RM with ZX, MJ with XY. And at first, it looks like both triangles are congruent because they both have a 1 ticker, a 2 ticker, and a 3 ticker. So it looks like side, side, side. But remember, they're asking us to prove it by triangle JRM is congruent to triangle XYZ. That's telling us that JR is supposed to be congruent to XY. JR, 1 tick mark, is supposed to be congruent to XZ, which has 2 tick marks. they're not matching up in this order. So triangle JRM, we can make that congruent symbol and put not congruent to triangle XYZ, but triangle, let's see if we can do this in order, JRM, I went down the 1 ticker, then down the 2 ticker, then the 3rd ticker. So I need to go down the 1 ticker, so that would be Y, Z, X. By side, side, side. They're congruent, but not with the triangles they asked. They're congruent with a different set for the reason of side, side, side. Here we're given 2 bits of information. We have to determine what would be the third part to make the triangles congruent if we were going to use angle, angle, side. So if we had 2 angles with 1 tick mark, 2 angles with 2 tick marks, and we wanted to prove them by angle, angle, side, we're going to have an option here. What would be the side that you would need to pick? 2 angles, and the side that's not in between those angles would be EF and TR. Or you could have picked 2 angles and the side not included. ED would be congruent to QR. Either situation would be the third bit of information to prove them by angle, angle, side. Now we're going to talk about angle E being congruent to angle R, side EF congruent to RT. Now we're looking for the third bit of information that's going to make those 2 triangles congruent to each other by angle, side, angle. Well, these 2 angles would need to be the same. So angle F needs to be congruent to angle T. Now the triangles are congruent by angle, side, angle. Angle D is supposed to be congruent to angle T. DE is supposed to be congruent to QR. And what would the third bit of information need to be for them to be congruent to each other using side, angle, side? DF would have to match QT. That would make the triangles congruent to each other.